Okay, today's notes are in section 1.5, application of quadratics. And what we're trying to do is just always solve them. We know how to solve them with the quadratic formula, factoring, and completing the square. I'll remind you how to do some of that in this section, but let's go ahead and do this problem. It says, find the dimensions of the open box if its volume is 1,435 inches cubed. So how do you find volume? Is just length times width times height. This picture will help us analyze which one's which. I'm going to call this one the length right here. That means that it is this. It asks us to take off these squares right here. That means we're going to not include them in our shape. So the length would be 3x and then minus 10 because of the 5 minus 5. The width, let's call it this one right over here. That means we have this distance. The width will now be x, which is the whole thing. Don't forget we're supposed to take off these two sections, so it'll always also be minus 10. And then your height is this length right here. Let's put the height right there. And that would be 5 because of these measurements right here. So the height is 5. We have to do length times width times height to get the volume. And substituting in, we have 3x minus 10 times x minus 10 times 5 is equal to 1,435. I'm going to go ahead and divide both sides by 5 just to have smaller factors, canceling that one out. And now I can also multiply this, and I do the box. So I have 3x minus 10 and x minus 10. 3x squared minus 30x minus 10x plus 100. So when I add these two together, it gives me negative 40x. That means that when I simplify that out, it would be 3x squared minus 40x plus 100 is equal to 287. Like I mentioned before, we could have factored, we could do the quadratic formula. Let me just tell you that the quadratic formula always works, always. So if you want to stick to that method, it is okay as long as your test doesn't tell you to use another method. So you're going to make sure you read the instructions. If it doesn't tell you which method to use, please use the quadratic formula. It always works. With the quadratic formula, though, it has to be set equal to 0. So I subtracted 287 from both sides. I have 3x squared minus 40x minus 187. The A is 3, the B is negative 40, and the C is negative 187. And I plug it in, and it says negative b, but we already seen the video about how to plug it in, so we can go ahead and start simplifying some stuff. Negative b would make it just 40, plus or minus the square root. And I go ahead and put it in parentheses because it's negative 40 that is squared, minus 4 times 3, because that's my a, and then c is the negative 187. All divided by 2a, which I'm just going to plug in. 40 plus or minus the square root. And when I put it in the calculator, I got 3,844. If you're not getting that when you put it in your calculator, please check. Please stop by and see what is happening with the order of how you're putting stuff in if you're not getting the correct answer. Divided by 6 is equal to 40 plus or minus, and this simplifies to 62. So I mentioned to you that the quadratic formula always works, but we had talked about in another section to always simplify the radical. In this section, you don't need to simplify the radical because its decimal answers would actually make sense. So for this one, if you got a decimal answer, that would be fine. So that means that if we add them together, you had 102 divided by 6. And I also mentioned that whether it was an or or an and statement, it is and because you have two answers. But in this one, it will be or, which is inclusive. That means that both and or would work, because one of these answers doesn't work. So if I do 40 minus 62, I get a negative 22 divided by 6, which is not possible. The answer cannot be negative 3.6. Length, width, height are not negative answers. That means that 102 divided by 6 is equal to 17 is your answer. And that's why on this case it is no or statement. It says find the dimensions. That's the value of x, not the actual dimensions. I'm going to go back up here. The length was 3 times x, which is now 17, minus 10, which I got equal to 41. The width is a 17 minus 10, which equals 7. And then by the given, the height is equal to 5. Do you have any questions? Let me zoom out just a little bit to make sure that everybody got it. Okay, on the next one. It says so that we're going to use the Pythagorean Theorem. To remind you, the Pythagorean Theorem is a squared plus b squared is equal to c squared, where c was the hypotenuse and a and b are the legs. I'll remind you as well what all of that means. So it says the long leg, and here they gave us that notation here that would be the longer side, is 20 longer than, so plus, twice the length of the shorter leg. That means that this shorter leg would be x. So whatever this length was, it's going to be 20 longer than twice that value of x. The hypotenuse, and the hypotenuse, remember, was the one that was opposite of that 90 degree. That's what makes it the hypotenuse. And it is the longest side. So when you get your answer, make sure that that answer is the longest. It says it's 10 longer than the longer side. So I'm going to put this on parentheses right here because it has to be longer than this. So 10 more the longer side. When you combine like terms, you have 30 plus 2x. And now we're using the Pythagorean theorem to solve for it. That means ax, a squared, which is x squared, plus b squared, 20 plus 2x squared, is equal to c squared, or the hypotenuse squared, 30 plus 2x squared. I always do the box, so I'm going to do the box for that second term, which says 22x, 20 plus 2x. That gives me 400, 40x, and then 4x squared. Add those two together, I got 80x. And then the other one on the other side, 32x, 30 plus 2x, 900, 60x, 60x, 4x squared. When you add those two together, 120x. So this can be rewritten. Don't forget that x squared right here for this one. And then all of this becomes plus 400 plus 80x plus 4x squared is equal to this one, 900 plus 120x plus 4x squared. I'm going to combine like terms and organize this just a little bit. This plus this makes it 5x squared plus 80x plus 400 is equal to 4x squared plus 120x plus 900. We want it equal to 0 if we're going to use either the quadratic formula or factoring. So I'm going to subtract 4x squared, giving you 1x or just x squared. Subtracting 120x from both sides, which would give you a negative 40x, and then subtracting 900, which would give you negative 500, is equal to 0. The quadratic formula works just fine for this one. I'm going to remind you how I factor. I put x squared here, the one without the variable here, so the constant. When you add these two together, it's supposed to give you a negative 40x. And you're looking for factors of negative 500. That when you add them together, they're going to equal negative 40. And there would be negative 50 times 10. Multiply together, give you that negative 500, and when you add them together, that negative 40. So this would be 50x, negative 50x, and then 10x. What they have in common is an x, 10, negative 50. That means that your factors are x minus 50, x plus 10. And that's equal to 0. X minus 50 is equal to 0 because you said each factor equal to 0. Add 50 to both sides to solve for x. X is equal to 50, and that is your answer. Because we're talking about length. X plus 10 is equal to 0 is not part of the solution because it gives you a negative x value. With that information, remember that they asked us for the length of the sides. That means that the short leg, which is x, equals 50. The long leg is 20 plus 2 times 50, which gives you 120. And then the hypotenuse is 30 plus 2 times 50, and that equals 130. Do you have any questions? Let me zoom out just a little bit, make sure you got all of it. Okay. The next one is a projectile is launched from the ground. Its height after the projection is given by s is equal to negative 16x, t squared plus 100t. This is very common, especially in physics. They always give you these type of questions. The first one, it says, after how many seconds will the projectile reach 50 feet? So we'll assume that this is talking about in feet. So we're looking at 50. So it wants to know the height of here and
1
here.
second.
Yes, sir. 1. So it's less than 1 second and a little bit close to the 6 seconds, but we're not going to estimate. We're going to find that quadratic